Hello and welcome to this module named Program Counter and ROM Memory Map, which comes under Unit 4 of 8051 Microcontroller. The name of the course is Microprocessors and Microcontrollers. Course code is ELC 104. Myself, I am Sunoj Raikar, Associate Professor at DM's College and Research Center, Asagaon, Goa. In this module, we are going to look at role of program counter register in executing 8051 microcontroller programs and program memory organization in 8051, ROM memory space of 8051 family of microcontrollers, then RAM memory organization in 8051 and 8052. After undergoing this course, a student will be able to explain the role of program counter register in executing 8051 program, discuss the ROM memory space of various members of 8051 family of microcontrollers, and explain the RAM memory space of 8051 and 8052 microcontrollers. As we have seen before in some of the previous modules, these are some of the most widely used registers of 8051 like A, B, R0, 2, R7 and all such things, DPTR, accumulator. Along with this, another important register is a program counter. So let us see the role of program counter register in executing an 8051 program. So a program counter is an SFR which points to the address of the next instruction to be executed. As the CPU fetches in the opcode from the program ROM, the program counter is increasing to point to the next instruction. Program counter starts at 0000H when the 8051 is started, and it is incremented every time after an instruction is executed. Program counter not only increments not Program counter is not always incremented by 1. Sometimes some of the instructions may require 2 or 3 bytes. In such cases, the program counter will be incremented by 2 or 3 bytes. The program counter is 16-bit wide. This means that it can access program addresses right from 00 hex to FFFF hex. That is a total of 64 kilobytes of code. In no way a program counter can access memory beyond 64 kilobytes of code. So let's see a program over here which has been written, and this is one of the program that is written here just to demonstrate the use of program counter and what happens to the program counter while we execute this particular program. So this is a program, and these are the ROM locations at which each and every instruction is going to be located. And once we assemble this particular program, this program is going to be generating a file called as a hex file, and once we download the hex file onto the ROM space or the microcontroller, the memory is going to be, the program memory is going to be filled in this way. So these are the addresses of the program memory, and this is where the data is going to go, or the program codes are going to go into the memory. So I tried to execute this particular program in using a cross-C compiler, or actually I made use of an assembler to demonstrate the program counter, how it increments. So the name of this assembler is the name of this compiler is SIDE51. So this is how it looks like once you have the program in the environment, and this is the simulation of the program. You can see once the program is started, the program counter is going to hold 000 hex. So these are the various registers. So we are going to pay attention only on the program counter now. So this is what is going to be the value of the program counter initially. Then we see that once we execute the first step, the program counter is going to be incremented by is going to point to the next instruction, and it is going to be 0002. Then next it's going to be 0004, and then it's going to be 0006, and once it goes ahead it's going to be 0007, and then 0008, and then finally 000A. So we have seen that it has incremented by 2 and by 1. So for all these instructions from move 5, move this first instruction, move R5 comma H25, or move R7 comma H34, and move A comma 0. Okay, this it was incrementing in 2 bytes. Then from here onwards it was incrementing in single byte. So that means these are all 2-byte instructions, and these are 1-byte instructions. So then we'll see the ROM memory map of different variants of 8051. So it goes like this. We get the basic flavor, that is 89C51. It is having a 4 kilobytes of RAM. Then we have 89C52, that is having 8 kilobytes of RAM. Then we have microcontrollers from Dallas computers. So DS89C420, it's having 16 kilobytes of RAM. Then DS5000, this is having 32 kilobytes of RAM. So if you go to see, this we can, depends upon our applications, we can select any one of this. So next we will see the RAM memory map of different variants of 8051. So we have already seen this before in the previous modules, that 8051 comes in 3 variants basically. So these are 8051, 8052 and 8031. So we'll focus our attention on the RAM now. So 8031 is having 128 bytes of RAM, and 8052 is having 256 bytes of RAM, and 8051 is having 128 bytes of RAM. So let's see how the RAM memory map of 8051 looks like. And here, the total memory, RAM memory of 8051 extends right from 00 to 7F, that is 128 bytes. So these 128 bytes are divided into different segments of memory. Here we can see from 00 to 1F, the memory is divided into 4 register banks, and each register bank is going to have 8 registers. So 00 to 07 is register bank 0, 088 to 0F is register bank 1, 10 to 17 is register bank 2, and so on. 18 to 1F is register bank 3. So, and from there above this, that is 20 to 2F, these are 16 bytes of bit addressable RAM. Okay, so altogether it will be 16 into 8 locations which can be bit addressable. Then above that we have 30 hex to 7F. This is called as the general purpose RAM. So the bit addressable memory is highlighted over here. We can actually access each and every bit over here, and whatever changes we require we can make in that particular area. Next comes the RAM memory map of 8052. As we all know that 8052 is having 256 bytes of RAM, so which is 002 FF. So this 002 FF is again 002 7. 7F is same way how it is for 8051, but above this also it's having area of scratchpad RAM. So 128 bytes of RAM extra are there for 8052, and these are sharing the same addresses with the SFRs. Of course, even in this also there are SFRs which are placed on the same, above this 802FF. Beyond 7F, the addresses are used for SFRs even in 8051. So 8051 is going to have this area for SFR, but 8052 is going to share the same area for SFRs as well as the RAM. Now, how to identify whether we want to pick a byte from SFR or whether we want to do something with the RAM? So if we make use of indirect addressing, then RAM is going to be used, and otherwise it will be SFR. So particularly in this area. Thank you.